Hello everyone, thank you for tuning in to this channel. In this particular video, we are going to be talking about one of the important phases in machine learning, which is exploratory data analysis. Exploratory data analysis is nothing but visualizing the data set and understanding some important trends and patterns in the data. After we understand these trends, we are going to take some action by telling it or explaining it to the business so that they can take action. After this step comes the feature engineering, where we give a new set of features that can make an impact in the model predictions. And finally, we take the best models and use that to make predictions and see how much of a value or an impact it can have in the organization. Now, this is the first phase where we focus mostly on exploratory data analysis, and the dataset that we consider is iris dataset, which is available from scikit-learn library. The first step is to import the list of libraries that we are going to be using for our task. Let me just import those libraries. I just say import cborn as SNS. Cborn is a library that is used for plotting. Similarly, we import matplotlib.pyplot as plt. These two libraries are used for plotting. We will also import the datasets library. So from sklearn.dataset import load iris data. After this, we are also going to import train test split, which is actually going to divide the data into training part and the test part. We use the training part to train our machine learning models and also see some important trends. We do not get access to the test data. We assume that that is the data that is present in real world. Therefore, we import that library as well. So I just says from scikit-learn dot model selection import train test split. These are the four libraries that I'm going to be importing. Now let me just load the iris dataset which is present. I just say load iris. Here we have a variable iris which takes into account the dataset. Now we are going to take the input features from the data. We just say iris dot data to get the input features. Similarly, we do the same thing to get the output label or the prediction that we want. So we just say iris.target. Now we are going to divide this data into train and test split. So we just give four variables: xtrain, xtest, ytrain, ytest, and then we use the train test split that we initially used, and we give the test size to be 0.3, which indicates that the test size has 30% of the samples. We also just assign a random state so that each time we repeat this experiment, the data is divided in the same or similar fashion. Now let us also print the shape of the data. We just say shape of xtrain, and then we are going to just plot that value here or show that value. Similarly, we just say print shape of xtest, and we give that value. We again get the shape of ytrain, and we just say ytrain dot shape. The last part is to get the test shape of the output features, and we give that shape here. And let me just run this. As you can see that there are 105 training instances for the train data, and we have 45 instances of the test data. And this is reflected for both the input labels and the output labels. X indicate the input labels and Y indicate the output or the target labels. Now if you're interested to know what are the output values, we are going to just define a variable called output names, and then we let us consider that to be target names and and then let me just print the output classes here so that we can get a better understanding of the outputs that are present. And I just say output names. let me just run this. So we have three different output values: setosa, versicolor, and virginica. These are the three outputs of iris flowers, and we are going to take a look at each of them. We are going to plot a few interesting plots. Let me now convert that iris data set into a data frame. I just say iris df equals to pd dot data frame, and I just give the xtrain parameter and also give the columns to be equal to iris dot feature names. Why we do this is, from iris we are getting all the list of features that we are giving to the models, and we are also, let us look at this data to get a good understanding. And we okay, because the pandas library is not yet imported, it gives that error. We just say import pandas as pd. Now once I run that, and if I just rerun this cell, here we get only the first five rows: sepal length, sepal width, petal length, and petal width. These are the four features that are given to the machine learning models. But now we are just interested in exploring the data and understanding some important trends and patterns. We will also take a look at the statistics of the data. We see that the mean of sepal length is 5.84. This is the minimum value, this is the maximum value. So we have the values for every set of features that we have considered. Now we'll use a basic plotting library called count plot. We just say count plot from the cpon library, and x is nothing but the target which we are interested in, and the data set is iris data. And we will just give it a title as distribution of iris species, and let us just take a look at this data so that it takes some time to load. So it says it cannot interpret the target because it doesn't have the target. So we need to do one thing here. We need to also give the target output. So we just say target, we give the feature name, and then we just give this one, so that now we have the output label, which is nothing but setosa, versicolor, or virginica, which are converted or are in the form of numerical values. And when we use the describe also, we have this additional feature called target. And now let us plot this to determine the target or the distribution. We see that most of the data points are of the category 2, which in our case is virginica. There are few samples from target 1, which is nothing but versicolor. And this is just one of the plots, but we do have multiple such plots which we can cover right now. And also we will look at the pair plot that will give us a good understanding about the data. So we just say hue equals to target, and finally we'll just plot the plots. Pair plot gives a list of all the plots, and scatter plots that can give us a good representation about how the data is split. Now this is a pair plot distribution. We see different categories. The target here are considered, they can be divided into three categories: 0, 1, and 2, which we have already seen above. And when we look at the sepal length and sepal width, we see that there is a clear separation for target 0 and target 1 and 2. In this case, the target 0 was setosa, and therefore generally we can just draw a line here which indicates the separation. That is how machine learning models also divide the overall points based on the boundary. We can easily classify or separate setosa. Virginica and versicolor are a little difficult to separate, but we see that for a few set of features like petal length and petal width, we are able to separate out those features. we saw that by exploring the data and understanding how the values are present, we are able to find interesting trends and patterns before we even give this to the machine learning model for predictions. Therefore, exploratory data analysis is an important step that we must consider before we can give our models for predictions. Thank you so much for your time, and I'm looking forward to publishing more content. And don't and please hit the subscribe button and turn on the notifications so that you stay up to date with more information. Thank you.